Alright, in the previous section we looked at parabolas where the equation was written in vertex form. And we saw in vertex form we can immediately find the vertex. Today we're going to look at parabolas in standard form, and we'll talk about how we find the vertex. Alright, so here's a parabola. And notice it looks like our vertex is right here. Looks like it's at 1, -4. Parabolas have a very interesting symmetry property. So I'm going to pick a y number. I'm going to start with an easy one. I'm going to pick y equals 0. And I notice this parabola hits at two places where y equals 0. This one looks like it's 3, 0. And this one, -1, 0. And here's the symmetry property. Notice if I go from -1, 0 to 3, 0, and I go halfway in between, that's where the vertex hits. And I could just compute halfway in between. To compute halfway in between, you add the numbers together and you divide by 2. That would be 2 divided by 2, which is 1. And let's do that again. Let's say I went right here. So this looks like it's the point 0, -3. And right here, we look like we have the point 2, -3. I have 2 points with this on the parabola with the same y value. My vertex is halfway in between. Halfway between 0 and 2 is 1. Alright, that property is going to be our whole key to finding the vertex. So here we have a quadratic equation, and this is written in what's called standard form. Standard form is a fancy way of saying we have y equals ax squared plus bx plus c. That's called standard form of a parabola. What we want to do is we want to graph this parabola. When we graph a parabola, the most important point to find is the vertex, so we're going to start by finding the vertex. And here's how we're going to do it. We're going to do an unusual thing. We're going to build a table. That's not unusual yet. The unusual thing is I'm going to pick a y value instead of an x value. Normally when we build a table we pick x numbers and we figure out y's. Here we're going to pick y's and figure out x's. From the symmetry property up above, it doesn't matter very much which y value we pick as long as we can find 2 points that have the same y value. Once we have 2 points with the same y value, the vertex is always halfway in between. To make our life easy, and we'll see why in a second, we're always going to pick for y whatever this number is right here. So I'm going to plug in y equals -2. And I'm going to get 2 answers. And we'll see why in just a second. Alright, so I'm going to take -2 equals x squared minus 6x minus 2. What I need to do now is solve that equation and find the x values. To solve that equation, this goes back to what we did back in chapter 8. We need to get 0 on one side, so I add 2 to both sides. And I get 0 equals x squared minus 6x. Alright, so this is why we picked this y value to be exactly the same as this number here. When we added, those will go away, and we're guaranteed that we'll have something that will factor. Because we can take out the GCF of x. And we're going to end up with 2 answers, x equals 0, x equals 6. So I've got 0 and 6. So what we know so far is we have this. We have the point 0, -2, and we have the point 6, -2. From up above, what we know from the symmetry property is the vertex has to be exactly halfway in between. Halfway between 0 and 6 is 3. So now I know my vertex is going to happen at x equals 3. I take 3 and I plug it in there. When I plug in 3, I get 9 minus 18 minus 2. That's -9 minus 2. That's -11. So I'm going to have the point 3 somewhere way down here, -11. And now I can draw my parabola. I know the vertex, the most important point, and I know at least one point on each side of the vertex. So there's my answer. Alright, so that's going to be our strategy for finding the vertex. Our strategy for finding the vertex is going to be to build a table, plug in a y number, not any old y number. We will always pick whatever number is right here. Solve. That'll give us 2 points. The vertex is halfway in between. Let's try that again. Alright, so to find the vertex, I'm going to build a table. I'm going to plug in whatever this number is right here, but I'm going to plug it in for y, and we're going to get 2 answers. So we're going to have 8 equals minus 2x squared plus 5x plus 8. We're going to subtract the 8 on both sides. That gives 0 equals minus 2x squared plus 5x. Again, the reason we picked this number 8 is so that those things do add up to 0. Those go away. That allows us to factor. We know we can always take out a GCF of x. Minus 2x plus 5. So we're going to get x equals 0. And we're going to have minus 2x plus 5 equals 0. We're going to subtract the 5. Divide by the negative 2. X equals 5 halves. Alright, so we have our 2 answers. 0 and 5 halves. Yes, sometimes you do get fractions. We'll have to live with it. So we're going to mark 0, 8. 5 halves, that's 2.5. So right about there. Now, halfway between, we take, to find halfway between 2 numbers, we add them together. We take 5 halves plus 0, that's 5 halves, and then we divide it by 2. 5 halves divided by 2 turns out to be 5/4. So I've got to take 5/4 and plug it into this equation. I'm going to use my calculator. Let's see, oops, let's see that. Negative 2 times 5/4, make sure you put that one in parentheses, squared, plus 5 times 5/4 plus 8. Now the calculator gives it as a decimal, 11.125. I would really prefer a fraction here since we've been using fractions. But remember where that is, 11.125. It's a little more than 11 when we go to graph it. And I am going to give my answer as a fraction, 89/8. So I'm going to mark my point. I've got to go halfway in between. It's right here. 5/4 and 89/8, which is a little more than 11, so I have to go up. And this makes sense, since this first thing was a negative. It makes sense that this parabola has to open downward, so it looks like that. Our vertex is a high point. Okay? Alright, I want you to try number 3 and number 4. And I'll tell you a couple things about them. Number 3, your vertex should come out to be a nice number. There shouldn't be any fractions in that one. Number 4, you will end up dealing with some fractions. So be ready for that in number 4. Alright. Determine the vertex of y equals ax squared plus bx plus c. What we're going to end up doing here is we're going to develop a little formula for vertex called the vertex formula. But we're going to do exactly what we've been doing. We're going to build ourselves a table. And we're going to plug in the number over here, which is c. Seems very strange, but it's going to work out nice for us. C equals ax squared plus bx plus c. I subtract the c on both sides to get 0 on one side. 0 equals ax squared plus bx. I can factor out the x. I would have ax plus b left over. So this is going to give me x equals 0, or ax plus b equals 0. 0 right there. Subtract ax equals negative b. Divide x equals negative b over a. So where is the vertex? Well, the vertex has to be halfway between 0 and negative b over a. So I would add these together. 0 plus negative b over a is negative b over a, and then I would divide by 2. So the vertex formula x equals negative b over 2a. And then what you have to do is you have to take that number and plug it in to find the y. Now, I find it interesting. People tend to have a hard time remembering this formula. I'm going to give you the way I remember it. Off to the side here. Almost everybody remembers this formula. Quadratic formula. Hopefully you remember that from end of chapter 8. I think we did in chapter 8. Anyway. Almost everybody remembers that formula. To find the vertex, you cover up that part. The vertex formula is just a part of the quadratic formula. Negative b over 2a. Okay? Alright, so let's use that. Determine the vertex, 1 point right of the vertex and 1 point left of the vertex, graph the parabola. So to find the vertex, I can jump right to my formula if I want. Of course, you can do it the way we were doing it before. X equals negative b over 2a. That's going to be negative 5 is 5 over 2 times 3 is 6. It's 5, 6. And then we got to find the y number. So we plug in 5, 6. 3 times 5, 6 squared. Minus 5 times 5, 6. Plus 2. Very small number. Just below 0. Again, I'm going to give it a fraction. Minus 1/12. Alright, so I start by graphing that. 5/6 is a little bit smaller than 1, and then negative 1/12 is just below the axis. 5/6, negative 1/12. And then it says 1 point right of the vertex and 1 point left of the vertex. So I'll just build a little table here. Let's see, 1 point left of the vertex, I could plug in 0. I like 0 because it's a very easy number to plug in. When I plug in 0, I get 2. 0, 2. Oops, that's 0, 1. Yeah, 0, 1. Forget about that point right there. There's 0, 2. And then I plug a number bigger than 5, 6. I'll go with 1. Seems pretty easy. Plug 1 in, I get 3 minus 5, that's negative 2. Negative 2 plus 2 is 0. So that would be right there. So my parabola looks like this. Okay? Alright, you go ahead and give number 2 a shot. And again, I'll tell you that for number 2, you should not end up with fractions like I did. You should end up with nice numbers for your vertex. Alright, that's the end of that section. So be prepared to turn this in at the next class, and we'll do more examples of this in class.